All right, I'm almost done and almost ready to put it all together and show you how to really easily graph um, from a vertex form, because now we know exactly where the vertex is, but we still don't know like how wide is this going to be? Like how are we going to figure out how to graph it once we know where that starting point of that vertex is? So I'm going to go over that real quickly and then we're pretty much done. A cat walked across me. Sorry, move. And so what we're going to look at is we're going to look at this something called a step pattern, and I know a couple of you were talking about it already, so you should be, most of you should be familiar with it. I'm just going to do a refresh and what exactly the step pattern means and how to use it for graphing. So what we're going to do is, well, chance. What we're going to do is we're going to look at from our vertex here. If I want to graph my next point, say we didn't have this arm, the rule is 1 over 1 up to get my next point, then another 1 over, and then 3 up to get my next point, another 1 over, and then 5 up to get my next point. So we call this a 1. You may have learned it a little differently. So 1, 3, and 5, which means I go over 1, up 1, get a new point, over another 1, up 3 from that second point there, because my vertex is my first point, and then I go over another 1 and up another 5, and that'll give me my first or a good section of the arm of the parabola, and that is when we're in the most basic form here. So basically that is when, oops, a is equal to 1. And I'm going to show you just in a second what happens when a is a little different. So now this graph is actually this one right here. It's y equals 3x squared. So my a is equal to 3. So it is definitely narrower. There is a vertical stretch that's happened from relative to the first one by a factor of 3, because that was my factor. So that is definitely going to affect our step pattern. And in fact, it's going to affect it in this way. So originally my step pattern, I'm going to write it here, step pattern, and this is from the vertex. So you start with your vertex. Vertex, doesn't like that curve. Vertex as h comma k. So I'm keeping it simple here, and we're just at 0, 0. And my step pattern is going to be that 1, 3, 5 in my regular one. 1, 3, and 5. So that again, originally on this equation here, meant I would go over 1, up 1, over 1, up 3, over another 1, up 5, and plot there. Now, but because you can see it's not fitting that, that pattern anymore because our a has changed. So the only thing you're going to do here is you're going to actually multiply each of these numbers by whatever the new a value is. So we're going to find the new step pattern. So here we're going to have 1 times, in this case, 3. So we're going to have, instead of a 1, 3, 5, we're going to have a 3. Here we have a 3 times the new a value, 3. So we're going to have a 3, 9, and this is quite a large one, 15 pattern. So we might not be able to graph all of this on the chart that I have here, but you'll get an idea of how that works. So instead of going up over 1, up 1, I'm going to go over 1, up 3. So I'm going to go over 1 here, and up 3, 1, 2, 3. There's my first point. And then I'm going to go over another 1 and up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, sorry, 9. And there we go. So that's our next step pattern. And then it would go from there, I'd go over another 1 and then up 15, whoops, to get my next point. So you can see the step pattern is affected by my a value. So this is pretty much all we need to graph now in vertex form. We'll do a couple as an example in the next segment. And we're going to start with a vertex and then use the step pattern, and it does depend on what our A value is.